What's up, guys? Today we're going to be going over the LeetCode problem number 207, course schedule. So basically, there are a total number of num courses that you have to take, labeled from 0 to num courses minus 1. You are given an array of prerequisites, where prerequisites I, A, comma, B, indicates that you must take course B if you want to take course A. For example, the pair 0, comma 1 indicates that you have to take course 1 to take course 0, right? And you want to return true if you can finish all courses, otherwise return false. Some examples are as follows. So there's two courses and the only prerequisites are that you have to take 0 before you take 1, then you can output true because you just simply have to take course 0, which has no prerequisites, and then you can take course 1. So taking both courses is possible. However, if you add an additional prerequisite that stipulates you have to take course 1 before you take course 0 as well, then that's obviously false, right? Because it's basically a cycle. To take course 1, you have to take course 0, but to take course 0, you have to take course 1. So it is impossible. So if you're given, thousands of these prerequisites, what is a high-level approach that will enable us to solve this? Well, this problem can be solved with the depth-first search algorithm. So before we can run this algorithm, we must first initialize a course to prerequisites map, and we should also initialize an empty visit set, which we will use during the course of the algorithm, right? And now for each course, we will run the depth-first search algorithm. What this entails is that if we find that the course is in the visit set, it means that we've run into a cycle and we cannot take the course. However, if the course has no prerequisites, as when we look in the map and we see that it has no prerequisites, this means that we can take it. Otherwise, we must do the main part of the DFS algorithm, which is add it to the visit set to indicate that we've seen it already, recurse this algorithm on each prereq, right? And if any of these prereqs return false, this means that we can't take the prereq and then we have to return false for this course as well. However, if all of them return true, then we can remove the course from the visit set and then set the course to have no prereqs in the course to prerequisites map and then return true. Now, if every course returns true, then we can return true, else we return false. So to more clearly explain, I'll give you guys a high-level walkthrough. So let's say this is our prerequisites list, right? These 5 examples. We'll say num courses equals 5. Now, what's interesting here is that we can represent this input as a graph. And what the edges in this graph mean is that you have to take the course where the arrow starts before you can take the course where the arrow ends, right? So simply put, I've represented the prerequisites list as a graph. And as we can see here, there's no cycles. This looks like a cycle, the 0, 1, 2. But if you look closely, you can't, because both these arrows go in the same direction, it's not truly a cycle because if you start at 2, you can't go all the way back to 2 in any way in this graph. So from a high level, we can see that we can take all these courses, but let's run the algorithm to programmatically verify that. So first, you want to initialize a course to prerequisites mapping, right? So taking each course, we want to, make a list of prerequisites that we need to take that course. So for 0, you have to take just 2. For 1, you have to take 0 and 2. For 2, you have to take nothing. 3, you have to take 2 and 4. And 4, you have to take nothing. And now we run DFS on each of the courses. So let's start at course 0, right? starting at course 0, we check for two things. Is it in the visit set? No, because we just started, so that's good. And does it have a prereq? It's according to the mapping. Yes, it has this prereq of 2, right? So this means we can't exit out of the algorithm quite yet. So what we do is we add 0 to the visit set, and then for each prereq that it has, so now the prereq is 2, we have to run DFS on the prereq. Okay, so run the DFS on its prereq, which is 2. So I'll just indicate 2. So now is 2 in the visit set? No. And does 2 have any prereqs? No. As you can see, it's empty. So what we do is we say we can take 2, and now we backtrack into 0. We say yes, this works. Okay, now let's go to 0's next prereq. Oh, there's no more prereqs left. This means that the one prereq that 0 requires, it can be taken. So this means that 0 can be taken, right? So now that we established that, we remove it from the visit set, and we initialize its prereq mapping to be null. So in the future, at any point, if we want to see if we can take the prereq, we can take 0. If it's a prereq for other courses, we can just quickly look into the mapping and then say yes. Okay, so 0 we can take, right? Let's cross this out. Now let's run it on 1. Is 1 in the visit set? No. Does 1 have prereqs? Yes, it has 0 and 2. So now let's put 1 in the visit set and run DFS on 0. However, we just saw that we could take 0, and we can verify that we can because the mapping list, it has an empty mapping that corresponds to it. So we can say that yes, we can take 0. However, now we have to check the second prereq of 1, which is 2. So we do the same algorithm. Is 2 in the visit set? No. Does 2 have any prerequisites? No. This means we can take 2 as well. And that was the last prereq that we needed to take 1, which means that yes, we can take 1, so we can remove it from the visit set. And we can set its list of prerequisites to none. Cross it out, and now we go to 2. Is 2 in the visit set? No. Does 2 have any prerequisites? No. So automatically we know that we can take it. Cross it out. Now we go to 3. Is 3 in the visit set? No. Does 3 have prerequisites? Yes. What are its prerequisites? 2 and 4. So let's first add 3 to the visit set before we run DFS on 2. However, we know we can take 2 because it has no prerequisites, so we say yes. Now let's do the same thing for its other prerequisite 4. Can we take 4? Yes, because it has no prerequisites. So this also returns yes. And because all of its prerequisites return yes, then 3 returns yes. So we can remove it from the visit set. We can nullify its prerequisites, make the prerequisite list empty, and then move on to the next course. And the final remaining course is 4. So is 4 in the visit set? No. And does 4 have any prereqs? No. Which means we automatically know that we can take this. So we can get rid of this, return yes or true for 4. And there's no more prerequisites. There's no more courses left to check, and all of them have returned yes, which means yes, we can take all the courses we need to based on this prerequisite list. So yeah, that was a walkthrough of one of the test cases. I would encourage you to try it with the test case that doesn't work, And uh, yeah, that's LeetCode number 207.